Okay, so good morning to everyone. Welcome to the lecture on electrical and hybrid vehicles. So this is the third lecture of module 1, and in previous modules we have seen the history of electric vehicles and why there is a need to do some research and development in the area of these electric vehicles, right? So the main cause was air pollution, global warming, as well as some depletion of petroleum resources, right? And in the last session, we have seen some introduction to electric vehicles. We have seen the generalized block diagram and what are the components, subcomponents used in electrical vehicles. Okay, so by now you are familiar with the construction of electric vehicles, right? What are the different parts available in that particular electrical vehicles? Okay, so today we will start with some vehicle fundamentals. Before we move on to the modeling of electric vehicle, we will know what are the parameters that were associated with the performance of the electrical vehicle. Okay, so this particular session, or in coming 2-3 sessions, we are going to discuss about vehicle performance speed, gradability of the vehicle, acceleration performance, fuel consumption, and braking performance of electric vehicle, right? So we'll start with the general description of this vehicle movement, right? So basically, the vehicle operation fundamentals mathematically describe vehicle behavior based on the general principles of mechanics. A vehicle which is consisting of thousands of components will be a complex system that we know by the time, right? So to describe its behavior fully, the sophisticated mechanical and mathematical knowledge is needed, right? So a great amount of literature of this kind is already exist. Okay, just we need to go through that particular literature, right? So in this particular subject, it proposed we are going to discuss the electric and hybrid electric powertrains. Okay, so the discussion of vehicle fundamental will be restricted to one dimensional movement only. We'll consider some one dimensional movement, and we know you already have done this particular in the, I think, standard 11 and 12 physics. Okay, so we'll start with the general description of vehicle movement and then we'll move on further, right? So our today's first topic is general description of vehicle movement, right? So now consider we are available with one particular vehicle and our that vehicle is moving in upscale. Okay, it is moving upward, right? So sorry, with the ground level, it is making some angle alpha, right? So this is my angle alpha. Okay? This one is ground level. This is my reference level. Okay, particular this, and my vehicle is moving up a grade. Okay, it is climbing this particular mountain or whatever uphill road is there, right? So now let us take the wheels of the vehicle. Right, pardon me for my drawing, but This is somewhat resembles the shape of a vehicle, right? Like this. Right? So this vehicle is going in upward direction with certain velocity v, right? Now we need to show some forces which are acting on a vehicle which is moving up a grade, right? So definitely we know that tractive effort is required. Okay, so suppose the full tractive effort which is in the contact area between these tires of the driven wheels and the road surface will propel the vehicle forward. Okay, and this tractive effort is produced by the power plant torque, and it is transferred through transmission and finally drive to the drive wheels. Okay, so while our vehicle is moving, there will be a resistance that tries to stop the movement of vehicle, right? And this resistance usually includes tire rolling resistance, aerodynamic drag, and uphill resistance. Okay, so whenever we talk about the resistance, then it will be tire rolling resistance, then aerodynamic drag, and third one is uphill resistance. Okay, it is also known as grade resistance. Okay, so this is the resistance offered to the movement of this particular vehicle. Okay, so now our vehicle is moving in this particular direction having a velocity of v, right? And we are applying some tractive force, right? So this tractive force has been applied over here, right? So this is my tractive force applied over here also. Let us call it FTR. Okay, and this is what propels the vehicle in the forward direction. Okay, why? Because this tractive force will generate some torque. Okay, and that torque is being transmitted to the via transmission to this particular wheels, right? So here let us say this is my wheels which will have some torque, say TRF. Okay, so this torque will behave in this particular direction. So it will be TRR and TRF. Okay, and this is the reason why our vehicle is moving up. Okay, now talking about the resistance. Okay, so as I have told you that the first resistance will be tire rolling resistance, right? So tire rolling resistance, what it will do, it will try to stop the particular movement of the vehicle, right? So this TRF and TRR are my resistance torque, rolling resistance torque. Then we have aerodynamic drag. Okay, so aerodynamic drag, we know if my vehicle is moving in particular direction, then air will resist the movement of the vehicle. Okay, so over here from the forward direction we will experience some force which is having which is in opposite direction to the movement of the vehicle. Let us call it FW, right? So this is my aerodynamic drag. And then third resistance is grading resistance. Okay, now grading resistance is over here. Say if we know the mass of this particular vehicle and we know the gravitational force, okay, so there will be one force acting in this particular direction. Okay, and that force is m into g. Let me call it mv into g, where mv is the vehicle of the mass, total mass of particular vehicle, and g is the gravitational force, right? So this will behave in this particular direction, right? Now if we divide this particular force into its x component and y component, then what we will get is, we will get the component, one component in this particular direction and another component in this direction, right? So this is mvg sin alpha, okay, and this will be mvg cos alpha. Okay, now here you can see this trf, trr are my tire rolling resistances, which will behaving in the direction opposite to the movement of vehicle. Then there is an aerodynamic drag Fw. This is also acting opposite to the movement of vehicle. And then there is one grading resistance, which is mvg into sin alpha. Okay, this is also acting in opposite to the movement of the vehicle. Okay, so these three are the resistances, right, which will oppose the flow of or movement of vehicles, right? So we'll discuss this resistance one by one, but let us try to understand the phenomena of the acceleration of this particular vehicle. Now we know this much forces have been there, right? And we all know the second law of Newton. So according to second law of Newton, according to Newton's second law, right, vehicle acceleration can be written as, say, dv by dt will be equal to total tractive effort, that is ft, divided by mass of the vehicle, delta mv, right? Now we have seen that we are available with the rolling resistance also. Okay, so we need to subtract this rolling resistance tractive force from the total tractive force, right? And this will be our equation number 1. Okay, so here if we talk about v, then v is nothing but vehicle speed. V will be my vehicle speed. Sigma ft is total tractive effort. Sigma ftr is total resistance, right? It includes the rolling tire resistance, aerodynamic drag, as well as uphill resistance, right? And then there is mv. As we know, mv is nothing but the total mass of vehicle. Okay, there will be two types of mass. One is dead mass and another one is the total mass. So dead mass means whenever we consider the dead mass, it will be the mass of vehicle only, and whenever we consider the total mass, that means dead mass, vehicle weight plus the weight of the people who are in the vehicle. Okay, so we will consider the total mass, and there is one term delta. So delta is nothing but the mass factor. Okay, so mass factor is nothing but it is an effect of rotating components in the power train. Okay, so this equation number 1 indicates that speed and acceleration depend on tractive effort, resistance, and the mass of the vehicle. Okay, so that we know. Okay, so this was the general description of the vehicle movement. This is how our vehicle will move. Okay, so this was the case of vehicle moving up a grade. You may have the case of vehicle moving on the flat surface, or vehicle moving in down a grade. Okay, so same equation needs to be applied in each and every case, right? So now we have discussed about these three resistances offered by the vehicle, right? The first one is rolling resistance, second one is aerodynamic drag, and third one is uphill resistance, which is also known as grading resistance. Okay, so let us see these resistances one by one. Okay, as we know, as we have seen in this particular figure, this vehicle resistance opposing its movement again includes the rolling resistance of tires, okay, which was TRF and TRR. Okay, over here, if you see, let me show you with this one. This is TRF and TRR, right? Then there is an aerodynamic drag FW over here, and then grading resistance, okay, which is mg sine alpha. Okay, so we will try to discuss all these resistances such that we will get some more idea how this resistance is going to affect the speed of electric vehicle. Okay, so let us start with the rolling resistance first. Right? Okay, so the name suggests the rolling resistance of tires on hard surface is primarily caused by hysteresis in the tire materials. Okay, this is due to the deflection of the carcass while the tire is rolling. Okay, this hysteresis causes an asymmetric distribution of ground reaction forces. Okay, the pressure in the leading half of the contact area will be larger than in the trailing half. Okay, let us see this phenomena with the help of some figure such that we will get some clear cut idea. Okay, so say this is my typical wheel. Okay, we will consider two particular cases. One is on hard surface and another one on the road, soft road surface, right? Okay. Here also we'll consider the center of the wheel like this, right? So now suppose my direction of vehicle is over here. Okay, this is the moving direction. So what will happen? This wheel will rotate in clockwise direction like this, right? Now this is my road surface. Okay, over here with a green line is my road surface, right? So if you can see, let me call this area as RD. Okay, and we are applying some force in this particular direction. Let us say this is my direction of force with the red color only. Okay, so this is the force we are applying. Okay, and what is the pressure? Pressure that will be applied in downward direction. Okay, so here we will be observing some pressure. Okay, and this is our moving direction. Right, and let us say the resistance of a wheel. Let us talk the resistor radius of the wheel as R. Right. So now this is my particular figure which shows the pressure in the leading half of the contact area will be larger than in the trailing half. Right? How? Let us see. So if this vehicle is moving in this particular direction, okay, it will try to put some pressure as I have shown the direction in the downward arrow. But what will happen? say this is the line with the green is our surface of the road. So you can see some part of the vehicle is in front area and some part of the vehicle is in downward area. So if I talk about the pressure applied onto the road will be like this. Okay. So this will be the actual condition. So this is my pressure P, right? And let us say I will define some area A over here, and let us say this is the clearance Z. Okay, so this is my surface of the road over here, right? So what will happen? This pressure, this phenomena will result in the ground reaction force shifting forward, right? So this forwardly shifted ground reaction force with the normal load acting on the wheel center creates a moment that will oppose the rolling of the wheel, right? So this is what happens. Now suppose I am talking about this soft surface. So on this soft surface, the rolling resistance is primarily caused by deformation of the ground. Okay, this was the hard surface where you can see the clearance. Okay, up to this. Now whenever we are on the soft surface at that time, this will be the case. See, now the clearance will be quite large. So this is my clearance Z. Okay, now what will happen in this case? This is the force we are applying. Okay, this one is the pressure, and this is my moving direction such that wheel will move in the clockwise direction. Okay, the radius of the wheel is same, that is R. Okay, now in this particular case, whenever we are on the soft ground, at that time what will happen? The pressure which is observed will be in the forward half only, like this. Okay, you can see the difference clearly. Whenever we are on the hard surface, at that time, okay, so this is my pressure. Say let us call it Px. Okay, so here you can see the ground reaction force. Okay, in this particular case, the ground reaction force is there in the forward half of the wheel as well as trailing half of the wheel. But in the second case, when we are considering the soft road surface, the ground reaction force almost completely shifts to the leading half only. Okay, so these are the two cases where we have seen the deflection and rolling resistance. Let's say tire deflection and rolling resistance on a hard surface and on a soft road or soft road surface, right? So now we are clear, right? Whatever ground force is acting in these two different cases will be different. So ultimately we are experiencing some resistance, definitely. Whenever it is hard surface, then we will be experiencing the force in half, leading half as well as trailing half, while in case of soft surface, the rolling resistance will be experienced by the leading half only, right? So the moment produced by the forward shift of the resultant ground reaction force, we call it the rolling resistance moment, right? And this rolling resistance moment can be expressed as, okay, let us define the rolling moment resistance. The moment produced by the forward shift of the resultant ground reaction force, resultant ground reaction force is called rolling resistance moment. Rolling resistance moment, right? And this rolling resistance moment is expressed as TR equal to P into A. Okay, let us call it as equation number 2. Okay, now what we need to do, in spite this rolling resistance has been offered, what we need to do is to keep the wheel rolling. Okay, so a force F acting on the center of the wheels will be required to balance this rolling resistance moment, right? As I have shown you here. Okay, this is the force required to balance the rolling resistance moment. Okay, so this force F is expressed as F equal to TR by RT. Okay, and TR we know, TR is P times A divided by RD. A by RD, let us call this FR. Okay, so this will be my equation number 3. Okay, so here RD, if I talk about RD, then RD is nothing but the effective radius of the tire. Okay, this is effective radius of the tire, right? And this FR, which is nothing but the ratio of A by RD. FR, which is ratio of A by RD, is nothing but the rolling resistance coefficient. This is rolling resistance coefficient. Okay, so in this way, the rolling resistance moment can be replaced equivalently by a horizontal force acting on the wheel center in the opposite direction of the movement of the wheel, right? And this equivalent force will be called as rolling resistance with a magnitude of, say, Fr is equal to P times Fr. Okay, so this is the equivalent force which is called rolling resistance with the magnitude of Fr equal to P times Fr. Here P is the normal load which is acting on the center of the rolling wheel, right? When a vehicle is operated on a slope road, the normal load P should be replaced by the components, right, which is perpendicular to the road surface. Okay, so suppose in this case, what is perpendicular phenomena? You can see it is mvg into cos alpha, right? So here this force will be replaced by, okay, say when vehicle is operated on a slope road, when a vehicle is operated on a slope road, in that case Fr will be equal to Pfr cos alpha, right? and this alpha is the road angle. Okay, this is already what we know. Alpha is nothing but the road angle. Okay, so this rolling resistance coefficient Fr is the function of the tire material, tire structure, tire temperature, tire inflation pressure, tread geometry, road roughness, road material, and the presence or absence of liquids on the road, right? So we need to consider all these parameters whenever we talk about the Fr, which is nothing but the rolling resistance coefficient. Okay, so this Fr rolling resistance coefficient is depending on tire material, then structure of the tire structure, tire temperature, tire inflation pressure, right? Then road roughness, then road material, presence or absence of liquids on the road, etc. Okay, and the typical value of this rolling resistance are already given in many of the data sets, right? So what we will do while modeling the electric vehicle, we will use this rolling resistance coefficient for different surfaces. Okay, so what are the conditions and what are the surfaces? Let us have a look on that particular case. So we'll try to see some typical values of rolling resistance coefficients. Right. So for that we need to see different conditions and value of Fr, right? So let us say first condition where our car tires are on concrete. Okay, so whenever our car is running on a concrete road, at that time the rolling resistance coefficient will be 0.013, right? Suppose my car tires are on rolled gravel. At that time, the rolling resistance coefficient will be 0.02. Okay. Suppose my car tires are on tar macadam, then the rolling resistance would be 0.025. Okay. And whenever it is on unpaved road, okay, which is nothing but the rough roads. Okay, so unpaved road, it will be 0.05. Okay, in the field, it will be from 0.1 to 0.35. Okay, and suppose we are talking about the rails. Okay, so wheels on rail, at that time the rolling resistance coefficient is 0.001 to 0.002 will be there. Okay, so these are the different values, right? Now for fuel saving in recent years, these low resistance tires for passenger cars have been developed and their rolling resistance coefficient is less than 0.01. Okay, so whatever value we have seen in this particular table, it will not take into account their variations with the speed. Okay, based on the experimental results, many empirical formula have been proposed for calculating the rolling resistance on a hard surface. Okay, say for example, the rolling resistance coefficient of passenger car on concrete road may be calculated from this equation. Okay. Say Fr is given by F0 plus Fs into V by 100 raised to 2.5. Okay, here V is the vehicle speed in kilometer per hour, F0 and Fs depends on the inflation pressure of the tire. Okay, when we talk about this F0 and Fs, they will depends on inflation pressure of the tires. Okay, so in vehicle performance calculation, it is sufficient to consider the rolling resistance coefficient as a linear function of speed. Okay, for the most common range of inflation pressure, we are using following equation, which is to be used on a concrete road, that is Fr is equal to 0.01 into 1 plus V by 100. Okay, so this equation predicts the value of rolling resistance coefficient Fr with acceptable accuracies for speeds up to 128 kilometer per hour. As per the some research literatures, this equation has been taken. Okay, so this is the generalized equation which we have used. Although, as I have told you, that number of empirical formulas have been developed by different researchers. Okay, so each and every researcher will use different formulas, but this is the generalized formula which is to be used for a passenger car on a concrete road. Right. So this is about the rolling resistance, how rolling resistance affects the performance of the vehicle. Okay, now let us consider the second resistance, which is nothing but the aerodynamic drag. Okay, we do know very well what do you mean by aerodynamic drag. Right, see, a vehicle traveling at a particular speed in air will encounter a force resisting its motion. Okay, and this force is referred to as aerodynamic drag. Simple, right? Say a vehicle traveling at a particular speed at a particular speed in air will encounters a force resisting its motion. Okay, and this force is referred to as aerodynamic drag. Right, so it mainly results from the two components. Right, it is the shape drag and skin friction. Okay, it results from, first one is shape drag and skin friction. Okay, we have seen the different shapes of vehicle, we know, right? So each and every vehicle will experience the different aerodynamic drag based on its shape as well as the friction which is offered by the skin. Okay, so talking about the shape drag, now the forward motion of the vehicle pushes the air in front of it. Okay, however, the air cannot instantaneously move out of the way, and its pressure is thus increased, and it will result in very high air pressure. Okay, so in addition, the air behind the vehicle cannot instantaneously fill the space left by the forward motion of the vehicle, and it will create a zone of low air pressure. Okay, so the motion has therefore created two zones of pressure that opposes the motion of a vehicle by pushing it forward and pulling it backward. Okay, so the resulting force on the vehicle is the shape drag. Okay, let us understand this with the help of some pictures, right? Say I am available with one car. Okay, so this is my car and this is the direction of movement. Okay, moving direction. Now what will happen when a car is moving in this particular direction? At that time the airflow will be in this direction, right? This is the way the air is flowing, right? Now here, whenever air comes over here, what will happen? It will flow in this particular direction, right? Like this. Because of this action, now what is happening is that at this particular area, if I talk about this area as well as this area, okay, these two areas will experience very high pressure compared to these two areas. Now this area and this particular area, this area will experience a low pressure, right? So this is experiencing high pressure, this area and this area, and here there are two more area on the back side of the vehicle which will experience a low pressure. Okay, and as we have discussed earlier that this particular will create a zone of two pressures. One is the high pressure and another one is the low pressure. Okay, so the motion which has created these two zones of pressure, that will oppose the motion of a vehicle by pushing it forward, that is high pressure in front, and pulling it backward, this is low pressure in the back. Okay, and this resulting force on the vehicle is nothing but the shape drag. Okay, so this is how this shape drag will work. Now another one is the skin friction, right? So what do you mean by this skin friction? Air that is close to the skin of the vehicle moves almost at the speed of the vehicle, while air far from the vehicle remains still. Okay, you can see from this particular case only, right? I am repeating, the air which is close to the skin of the vehicle, it will move almost at the speed of the vehicle. Okay, and the air which is far from the vehicle will remain still at a wide range of the speed. Okay, so the difference in speed between the two air molecules will produce a friction that result in the second component of aerodynamic drag. Okay, so aerodynamic drag is a function of vehicle speed v, vehicle front area af, shape of the vehicle, and air density rho, right? So the aerodynamic drag will be expressed as Fw is equal to half rho AF CD into V plus VW whole square. Let us call it equation 8. Okay. So here CD is the aerodynamic drag coefficient. CD is aerodynamic drag coefficient, right? And it will characterize the shape of the vehicle. Okay. If we talk about the VW over here, then VW is the component of the wind speed on the vehicle's moving direction. It is component of the wind speed. Okay, and it has a positive sign when this component is opposite to the vehicle speed, and it will have negative sign when it is in the same direction as a vehicle move. Okay, so this aerodynamic drag coefficient for different types of vehicle body will have different values. Okay, so like we have seen this in a previous of tire rolling resistance in this particular table where different conditions are there. Same is the case with the aerodynamic drag with different shapes also will be available. Okay, and then there is the third resistance, which is the grading resistance. Now, when a particular vehicle goes up or down a slope, its weight will produce a component which is always directed to the downward direction, right? That is what we have seen in the previous case. Okay, let us go back to the figure over here. Okay, you can see mv into g. So this is the component, this is the force which is acting in downward direction, right? So this component will either oppose the forward motion whenever it is climbing grade, or it will help the forward motion if it is grade the grade is descending, if my vehicle is moving in a downward direction, right? So in vehicle performance analysis, only uphill operation will be considered. Okay, and this grading force is usually called grading resistance. Okay, so this is what our resistance is, right? And the grading resistance can be expressed as Fg equal to mvg sin alpha. Okay, let us call it equation number 9. Now to simplify the calculations, the road angle alpha is usually replaced by grade value when the road angle is very small. Okay, so the grade is defined I is equal to h by L, which is nothing but tan alpha, which is approximate equal to sin alpha. Okay, let us call it equation number 10. What is h by L? Let us go through this figure one more time. Right, so here say this is my total length of the vehicle, right, L, and this is the height, which is h. Okay, so grading is nothing but the grade is nothing but the ratio of this h by L, which is tan alpha, and which is approximately, which will be approximately equal to sin alpha whenever the road angle is very much small, right? So in some literature, you will find the tire rolling resistance and grading resistance together, they are called as road resistance. Okay, in some books or in some papers, you will find this term road resistance. Okay, So road resistance is nothing but the tire rolling resistance and grading resistance together. Okay, and it is denoted by FRD, which is the summation of rolling resistance plus grading resistance. Okay, so it will be equal to MV into G FR cos alpha plus sin alpha. Okay, let us call it equation number 11. Right, and in this case, if our road angle is small, when the road angle is small, okay, this was also the case when road angle is small. Okay, if road angle is small, so when road angle is small, now road resistance FRD will be equal to FF plus FG, and it is equal to MV into G FR plus I, which is my grade. Okay, so this is the equation which we are going to use in order to find out the different resistance. Okay, so this is my total road resistance, which is nothing but the summation of rolling resistance plus grading resistance. Okay, so this is all about the resistances offered while the movement of vehicle is being done, right? So we know how we will be able to find out this resistance, and we will be able to calculate the required tractive effort to move or to accelerate the vehicle in forward direction, right? So we shall stop here for today. In the next session, we'll try to identify some dynamic equations of the vehicle, right? And then we will try to find out the maximum value of the tractive effort which is required to speed up the vehicle, right? So we will stop here for today. If you have any questions, then you are free to ask.
Yes, sir. Sir,
Yes, please.
you will say that one equation of FR